So welcome, and again, this is where we stopped last time before the song. This is where we stop in terms that we in 2.2 relate to subset, and there are two items that we mentioned is how can a set be a subset, and how can a set be a proper subset, right? We went over this item, and this is where we stop in terms that reminder, a subset is the first item have to be a portion of the second item. And, oh, we didn't go over this. The first item have to be a portion of the second item. Or the second item have to contain whatever the first item have. And I believe we went over all of this last time in the sense of this item here that they are not if they are not a subset, they won't be a proper subset, right? Why they are not a subset? Because again, the second item does not have everything the first item offer, right? The second item, this item here, do not have red or yellow, right? So again, they only they cannot be in a subset because in order to be a subset, the second item have to contain whatever the first item offer, whatever the first item have. Okay, so again, this is what we have. We went over, and this is where we stop in the sense that the last thing that they ask you is, how can you calculate? If we give you a set, if we give you a finite set, and if we know the item, how can you calculate how many subsets we can have, right? So if I give you a set contain X amount of item, how do we know how many subsets do we have? Well, this is probably the only calculation you have, which is to find the number of subsets is basically n 2 to the n power. 2 to the n power, which is 2, will always be your base, which is 2 to the n power will be the number of the subset. And vice versa, 2 to the n minus 1 will be the number of proper subset. And why is that 2 to the n minus 1? And again, hopefully you guys see that the reason why we subtract 1 is because that 1 is the even or the equal set, right? So looking at this thing here, let's say if I give you this item, let's say if I give you this set A, whatever this set A is, contain A, D, G, J, T, Y, U, E, right? So if they give you, or if I give you this item, and the question I ask you is, how many possible subsets should I get? So if you look at this thing here, we know that we have 2, 4, 6, 8 elements, right? 8 individual distinct elements. And to find the number of subsets, all you need to do is take 2 raised to the 8 power, which is 2 raised to the 8 power, meaning 2 times 2 times 2 times 2 times 2 times 2 times 2, 8 times, which is 2 to the 8 power will give me 256. And that is the number of subset. And the number of proper subset is just 256, which is 2 to the 8 power minus 1. And why is minus 1? Because of the individual set itself. This set, A, D, G, J, T, Y, U, E, this set cannot be a proper subset because they are equal. Reminder, in order to be a proper subset, the two sets cannot be equal. They are subset and also not equal, okay? And similarly, if I give you this set B, right? This set B, blue, green, red, black, purple, which is, looking at this thing here, you can see that we have 5 elements. And if we have 5 elements, how many subsets are there? What is the total number of subsets can we get? Which is the total number of sets that we can get is n is equal to 5 because we have 5 elements. 2 raised to the 5 power, which is 2 times 2 times 2 times 2 times 2, which is we have 32 subsets. And then from the 32 subset, we know that we have 31 proper subset. Okay. So looking at this thing, this is what they ask you in terms of how would you go and calculate the number of subsets and the number of proper subset. Okay. So question of how to calculate this subset versus number of proper subset here. the next item they ask you, which is you did the Alex, is sometimes it's a little bit confusing, which is they want you to use the idea to apply to a real world situation. So let's take a look at this thing, which is the last thing in 2.2, or second to last thing, is if we can calculate the number of subset and the number of proper subset, can you list them out? Can you list all of the subset out? And looking at this thing here, to list, if I were to ask you to calculate S, right? Do you see that if you calculate S, which is 2 to the 2 power, 2 to the 2 power meaning 2 times 2, which is we know that we have 4 subsets, right? Why? Because fever and headache is 2 items, and 2 to the 2 power, which is 2 times 2, we have 4 individual subsets. So now the question not asks you to calculate, the question asks you to list. And if you list this thing here, for me, I like to start with an empty set. Why? Because remember last time we have that discussion that an empty set is a subset of every single set there is. As long as you have a set, doesn't matter what set you have, an empty set is a subset of that, which is an empty set, which is an element contain 0 element, which is an empty set is a subset of that. The second item is, again, I start with the 0 element and I start with a 1 element, which is the set contain fever is a subset of fever and headache. The set contain headache by itself is a subset of fever and headache. And then I go and I finish, which is the set of fever and headache is a subset of fever and headache, because every set is a subset of itself, right? So looking at this thing here, as you can see, we have, if you look at this thing here, we can see that we have 1, 2, 3, and 4 subsets, right? Those are the 4 individual subsets. We calculate 2 to the 2 power, which is 4, and that's what we have, okay? And one thing is on your homework on Alex, this is what they ask you, a little bit confusing, or not confusing, but they challenge you to think in terms of real world, right? If they ask you, well, before I mentioned that, let me ask you, if we have 4 subsets, everybody see why we only have 3 proper subsets. The reason why we have 3 proper subsets is because this set, right? Because of this set right here, because of this set, they are equal. And because they are equal, they cannot be proper. So in terms of this set right here, they can be only subset, but they cannot be proper subset, which is the actual set itself. So therefore, we only have 3 proper subsets, because one of the subsets is the same as the original set. And if they are the same, they are equal. And if they are equal, they cannot be proper, okay? So that's why we have to minus 1 here, 2 to the n minus 1. That's why we have that item there. So once we have this thing here, like I mentioned earlier, Connect or Alex, they ask you this question is, let's say that this is the syndrome for flu. I don't know. Let's say that this is the 2 common syndrome before you get a flu, right? And they ask you, well, if how many set can you get? List the set that doesn't contain both syndrome. So if they ask you for list sum, which is again list the set that does not contain both syndrome, then you only list this 3 item, which is again you might not have any syndrome and you still have a flu. You might have 1 syndrome, you might have 2 syndrome, right? Or if they say list the set, right, exclude the one that you don't have any syndrome, right? If you exclude the one that doesn't have syndrome, meaning you cannot list this item here. You can only list the fever, the headache, or this, meaning some, right? Some, not all, or none. Again, those are the questions that you will see on Alex a few times that they ask you is list some. If you list some, you cannot include a nothing, right? Some or some and not all, which is again, some and not all, you cannot list this item. Okay, but again, let's go back to list this item here. Let's say if we have this information, let's say that you're going for your drive, let's say the set D is equal to, you go get gas, you go get food, you go get some drink, right? So now they ask you to list a subset, right? Let's say if you go out and you try to you list this item here, what can you do? Well, one thing is you can drive, right? Think about this in real world, right? This is, you go for a drive, and when you go for a drive, you can go get some gas, go get some food, and go get some drink. And they ask you, well, is there any way you drive and not get any of this thing here? Which is yes, right? You can drive and you can go watch the movie, right? Which is, do you see the empty set? Meaning you just go drive just to drive, or you go to your friend's house, right? An empty set meaning you drive and you don't get any of this thing. You just go out for a drive, right? And then a set of one item, which is you can either go drive, get a gas, go home, go drive, get some food, go home, drive, get some drink, you go home, right? So again, this is the list that you drive and you don't do any of the three activity. This is the list that you go and you do just one activity, right? Or you can go drive, get gas and food, go get gas and a drink, go get food and drink, right? Meaning again, this is when you go out, you do go for a drive and you do two items. And then you can go drive and do all three items, right? You can go get a gas, get food, and get drink. So again, the idea of Alex and most of the question in Alex, they want you to think in terms of the real world situation in the sense of that, which is, again, as you can see, if you look at this thing here, we know that there are three elements, and we know that 2 to the third power is equal to 8, which is we have one subset, two subset, three subset, 4, 5, 6, 7, and 8, which is we have 8 different subsets here. So if they ask you to list, and they ask you to list, which is, again, if they ask you to list some but not all, meaning you only list this item and not the equal item, okay? And you cannot list a empty set because the empty set doesn't have some, okay? So again, be careful when you do your Alex, they ask you in those nature of the wording. But to sum it up, for me, when I try to list the subset, for me, I always start with 0, 1, 2, and 3 if I have 3. They won't ask you to list all of this subset here because it's a lot, right? 32 of them, you know, sometimes you will miscount. Or they won't ask you to list all 256 subset because that would be a humongous subset, okay? But again, go back to this thing here, question of how to calculate the number of subset, how to calculate the number of proper subset, or vice versa, how to list the subset, the actual set here. Any question with this two item, calculate versus list them out? All right, if you don't have question, let's take a look at this item here, which is the last item we have. And like I mentioned, this is the last definition that you will see. After this thing here, you just do problem relate to all of this item here. So one thing is the Venn diagram. The Venn diagram is just basically this item here, which is for our Venn diagram, instead of just tell you that this set contain this set contain that, the Venn diagram give you a visual idea of how your set is, okay? So that's contain two items, which is in this Venn diagram right now, you have two items, which is we have a set, we call set A, which is that red circle item. That is set A, meaning if it's in the circle, then it's in set A. It's the item inside A. Or if it's in the universal set, which is, again, we call this universal set, which is we cannot name our set a U, or in terms of this thing here, the U, capital U, represent your universal set. And just like the name universal set, meaning the set contain everything that we deal with in our example. It's the universe. If it's not in this universal set, we don't care about it. We only care about the item in my universal set. Okay, so the other thing that the other last three definition here, ladies and gentlemen, which is a complement of set, and you have only two options. Inside whatever your Venn diagram, you have two options. Is you either inside set A, or we say outside of set A. And when you're outside of set A, we call you a complement of A, or you will hear me say A prime. Okay, so again, this prime, this caret sign, you will hear me say a lot of A prime, which is when you read this in English, it's basically tell you that the item outside of set A, not in A. But it's still in our universal set because it still deal with the item that we work with. Okay, they won't ask you for the U prime. They won't ask you for the complement of the universe. Your universe is an item that we deal with in our problem. They won't ask you for the complement of that. It's either complement of A, meaning outside of A, or complement of B, outside of B. Okay, so the complement, which is the prime, the symbolic is the prime, which is the caret sign, which is basically tell you that the item not in A. Okay, the other two definition, which is the intersection of set, and the notation for intersection of set is the upside down U, which is again is referred to the word and it's very important, which is again, this is basically tell you that the element inside both A and also in B. Okay, so one thing I tell my student, ladies and gentlemen, is whenever they ask you to find the intersection, you have to give them what is the one thing that they both share. Okay, the intersection, you won't see the Venn diagram. The next slide, you will see the Venn diagram. But again, the intersection is basically what is in both A and also in B. And the last thing we have is the union. The union, which is the word that illustrates with the union is the word or, which is what is in A, or in B, or in both. Okay, so I tell my student is if they were to ask you for the union, A union B, basically you combine them together, you unite them together. Whatever in set A, you just add them with in set B. If they ask you for the intersection, you give them what they have in common. Okay, so for the intersection, you give them the common item, the common element, the common member. But for the union, you combine them together. Whatever in A, you combine them within B. That's the union, unite them. Intersection, common. Okay, so looking at this thing here, let's take a look at the Venn diagram, which is there are 4 different Venn diagrams for us that you will see that relate to 2 set. So if we have the 2 set, so the first figure, this thing here from your book, which is again, make sure that you see that the A, the B is inside the A. We call this a proper subset because everything in B is also in A, which is reminder that this is B is proper subset of A. Why? Because A contain everything in B. Okay, again, A consume B, meaning everything in B is also in A. It's just that A have more than B. Okay, and that's why they are proper subset. You will see some of that, and this is the intersection of A and B, which is the intersection of A and B is basically tell you that what is inside both A and B, right? Meaning what does A and B share, which is this is the common item. This is the only common item we have, okay? And we have a disjoint set, and the disjoint set is just like the name. The disjoint set is basically the 2 sets are disjoint each other, meaning both of them, A and B, do not have anything in common. The only thing they have in common is an empty set, meaning nothing at all, right? Whatever in A is in A, whatever in B is in B. They do not share anything. They in the universe, but they are not sharing anything. And lastly, you probably won't see a lot of this, but this is just an equal set, meaning again, A and B is equal, it's the same set. So if you have A and B like this, meaning again, whatever in A is also in B, which is A and B is just one set. Okay, so but you won't see the last item a lot. You will see the most Venn diagram you see is this. Okay, and again, I have a small explanation here, which is again, proper subset is just basically everything in B is also in A, which is again, whatever in B is in A, that's the proper subset. And the intersection set is basically, again, whatever A union B, if you look at this thing here, A intersection B, which is what does A and B share, which is again, the pink item, that's what A in A and in B. If you look at the red, if you read this, and again, if you attempt Alex, you probably saw a few things like this, which is again, for this figure, if you read this thing here is what is in A and not in B, right? If you can see that this thing here is in A, but it's outside of B, which is B prime. So the item inside A, but not in B, or inside A and not in B. Or vice versa, if you look at the blue item, this is basically outside of A and in B, or vice versa, in B, but not in A, right? So it's in the B circle, but it's outside of A circle. Okay, give me the item inside B and not in A. Okay, and vice versa, if you see this thing here is basically is an item outside of A or outside of B. Okay, the item that outside of A that is not in A, none is in B. Is neither in A, none is in B. So it's an item on the outside. Okay, so those are items. We will take a look at more of that in a bit in example. But the idea of this thing here, the one thing or the most important thing that you will see is how can you take this notation and translate to a common English language that you can understand. Okay, and that's the most difficult thing, is how can you take those common English and turn to symbolic, or vice versa, from symbolic turn back to the common item. So again, the last two items, which is like I say, this thing have nothing in common and this thing have the equal set. Okay, so let's take a look at this example before we do the real item. So the last thing we have in 2.2 is how can we use that two definition or three definition, the complement, the union, and the intersection. How can we use that to find my item? So let's say that they give you this information. They give you the universal set, and the universal set is basically, okay, this is my universal set. It's contain A, B, C, D, F, G, H, I, J. My A set, my B set, and my C set, right? And this is what they ask you is find A prime, right? So if you look at this thing here, how can you find A prime? We might, one thing about A prime is basically the complement of A. So this is why I tell my students to find A prime is basically whatever in A, throw it away. Basically whatever in A, you don't want it. Give me whatever left from the universe. Do you agree that C is in A? We don't want C. D is in A. We don't want D. E is in A. We don't want E, F, and G. So do you agree that this item is inside A? So basically A prime is give me whatever that is not in A, but is in the universe. We only compare to the universal set. So whatever outside of A, but in the universe, doesn't matter in B or in C, I don't care. Whatever A prime or whatever the prime is, you always looking for the item outside of A, but in the universal set. Okay, and similarly, looking at this thing here, we can find this. For me, I like to find it like this so that I can go back and do the reference later, right? For A prime, basically, I cross this thing out. The leftover is A, B, H, I, J, and for B, if you look at B, which is again, what is in B? Do you agree in B is A, C, E, H, and J? So again, this is in B. So what is left over? Left over is B, D, F, G, I. So the complement of B is basically whatever left over from the universal set. And vice versa in C. What is in C? In C, we know that we have A, B, D, and G. So looking at this thing here, what is left over? I still have C, E, F, H, I, J. So again, A prime, B prime, and C prime, I can just find it like that in the sense that all I need to do is cross whatever in A from the universe. Whatever left is in A prime. Cross whatever in B from the universe, whatever left from the universe is in B prime, and cross whatever in C from the universe, and whatever left is C prime. I know I don't ask you B, C, but again, we can do that so that later if we have this, if they ask you the question, you can use it as a reference, okay? So looking at this thing here, let's go into the second question, which is they ask you, if you were to read this, they ask you A union C. And A union C, reminder you guys, all we need to do for the union, this is what you need to do for the union is take whatever in A, and unite them or add them together or combine them together with whatever in C, okay? So in short, basically whatever in A, union, combine them with whatever in C. And if they happen to repeat, we just write it one time. And again, this thing here, all I did was I put in order, which is A, B, C, D, E, F, G. So again, the D and the G, they repeat it. And if they repeat it, I only write it one time. But again, in short, the union. In short, the union is basically combine the two together. Take whatever in A, put it together with whatever in C. So A union C is combined in A together within in C. And similarly, let's do this thing here, and then I will ask you guys if you have questions. Similarly, if you read this thing here, B intersection A. So B intersection A, this is a little bit different in the sense that for B intersection A, or the intersection, like I mentioned, is what does B have in common with A? So the difference between the union, you combine them together. For the union, you combine them, you unite them. But for the intersection, you have to ask yourself, what is in A that is the same as in B? Or in this case, what does B have this common item as A? So do you see that looking at this thing here, the only two common items they have is C and E. They don't have any other common item, which is the intersection. And that is what you guys, that is the main goal for chapter 2, is you have to know the definition of the union, the definition of the intersection, and the definition of the complement relate to your set, okay? The complement is what is outside of that region, what is not in that region, that's the complement. The union is you unite the two regions together. You take whatever in the first item, combine them, unite them, add them together with the second item. That's the union. The intersection is what does the two items share? What do they have in common? So again, looking at this thing here, question with A, complement, B, union, C, intersection. And again, you have to know how to translate the symbolic to the English item. So first of all, question with this A, B, or C. All right, let's take a look at this thing here. And again, if you read this item, you know, and this is the reason why I do this thing here. I do the A prime, B prime, C prime, because you know, because I come up with a question, I know I need it eventually, right? I know I need A prime, B prime, C prime eventually. And if you look at this thing here, if you were to read this, ladies and gentlemen, if you were to read this, you would say, give me the item outside of B or the item inside C, or B complement union C. Meaning, again, union meaning you combine them together, which is if you combine them together, we can see that this is B prime. The complement of B is this item right here. We did this before. Take that item and combine them with this item we call C. So we have the region outside of B, put that together with the region in C. So if you do this and if you put them in order, and I try it, Alex doesn't need to be in order, but if you, I'm missing an F. If you put them in order, again, if you put them in order, it's A, B, D, F, G, I. I forgot the F here. So again, there's an F here. There should be an F in here. Okay, so again, A, B, D, F, G, I. And if they happen to repeat, you write it one time. So make sure if you do this, make sure there's an F here in D. So A, B, D, F, G, I. All you do is you take the two items and you combine them together. And that's why I create the A prime, B prime, and C prime, because if I have it as a reference, if I have it as a reference, all I do is I take that item, combine with this item. Okay.